Okay, so for one-side limits, for limits, most of the time you're just gonna plug in the number. If you get a number, you're pretty much done. And if you got 0 over 0, that's where you have to do those 4 situation, which those situations kind of like overlapping between the 4 situation. So the first situation is you have to make sure you factor, and then you cancel factor. And this we already talked about before. And if you have a radical, it's gonna be a deal with the conjugate. And if you have a complex fractions, you're gonna be simple combined fractions. And sometimes you will get a absolute value, which is yesterday's last question has absolute value. So this kind of have a very similar to situation on the other side, which is you can also get a number over 0 situation. So this one I told you that I will talk about it here. I would say that questions more belong to number over 0, even though it doesn't have to. It can be 0 over 0. So you don't know. So if you have number over 0, pretty much you got a 3 possible result. But the things that you're gonna do is you're gonna do something called one-side limits. Now, one-side limit can be including for 2 different things. One just straight one-side limits. So one is one-side limits. What do you mean by that? Just like limit as x approach to 2 from the left of 1 over x minus 2. That's called one-side limits. You can also approach, you can do one-side limits for both sides. So it's called one-side limits for both sides. So this one, usually you're gonna get 2 results, infinity and negative infinity. This might get 3 results. You got infinity, negative infinity, and does not exist. So you're gonna do something called one-side limits. And you're gonna be like, what is one-side limit? But here's the thing. Where do you have to do one-side limit? Like which kind of function you have to do one-side limit? Like in what situation you have to do one-side limits? Yes, which kind? There's 2 kinds of discontinuity. Asymptote, or a non-removable discontinuity. Yeah, so who said non-removable? Good job. So non-removable discontinuity is, so I would say, I kind of say, there are 2 types. There are jump, and they are asymptote, especially vertical. And we are talking about strictly vertical asymptote. We're also going to talk about jump as well, which is absolute value has a jump. But vertical asymptote is something called non-removable discontinuity. Now, I didn't talk about last period, but there is something called removable discontinuity. That is a whole. That means if you have a cancel factor. If you have cancel factor is the whole, then you got a removable discontinuity. But strictly that we are talking about that you have to do one-side limits, usually located at this particular spot and this particular spot. Jump occur in absolute value. Asymptote, vertical, we're going to give you an example of 1. So let's just say when limits x approach to 2 from the left of 1 over x minus 2. What you're gonna do is you're gonna plug in 2 in there before you're approaching 2. So if I plug in 2 in there, what will happen? 1 over 0. And if it's 1 over 0, that's automatically, you say, okay, 1 over 0, that means there's 2 possibilities for 1 over 0. You can be either negative infinity or positive infinity. But how do we decide that? Usually I'll plug in that instead of 2, I'll plug in 0.1 away. Because at 0.1 away from the asymptote, usually it will tell you if a function gonna go negative infinity or positive infinity. So what I'm gonna do is I'm gonna plug in 1.9 minus 2, and that's gonna give you a negative value. If negative value means negative infinity. So the answer is negative infinity. Does that make sense or no? I'll show you graphically that way to help you, right? And tomorrow we're going to talk about a lot of graph. So 1 over x minus 2. And if you graph it, it's going to show up like this. But if you do 1.9, guess what? If 1.9 is right here. And the asymptote is, so if you 1.9, it's like 0.1 away from the asymptote. Usually they can tell that if the value is negative, then it's pretty much gonna go to negative infinity. Does that make sense? Because it's below x-axis, more likely that's gonna go. So that's why you choose 0.1. If you choose 1, then sometimes if you choose 1 here, it doesn't tell are you going to a negative. So I would choose 0.1 away from the asymptote and just plug in the value, see what your sign is. Because sometimes if you have a little bit of shift, this line might be over, you might show it's positive infinity. But if it's 0.1 away from the asymptote, which is asymptote is located at x equal to 2. So, and like this. So more likely you can tell that trend is going to a negative. If it's negative, it's going to be negative infinity. Is that okay? So just plug in a value. Not something crazy. It's actually pretty easy. So I wasn't even going to assign a homework today because it's so easy. All you got to do is plug in a value very close to the asymptote and you try it. But you guys do need to understand it's not that hard. Yeah, so if I would have said limits x approach to 2 from the positive side of x minus 2, then what value I will plug in? Well, I will plug in 2 first. That's going to be 1 over 0. That means is one side limit is negative infinity or positive infinity, right? So then I'm going to say 1 over 2.1 minus 2 is 1 over 0.1. So it's positive. So it's positive infinity. Because it's positive value, it's going to go to positive infinity. So that is positive. And that's why I say if the one side limits is giving, right? Usually you're going to get either negative infinity or positive infinity. Because you can reach from the 2 to the left side or 2 from the right side. Now, what if you ask a question like this? Limits x approach to 2 of 1 over x minus 2, like this. I didn't tell you from the left side or right side. What are you supposed to do? If I don't tell you left side or right side, what are you supposed to do? Do both. You do both sides. And which is we already did. And the conclusion is going to be does not exist due to this. Right? Because one is going negative infinity, one's going positive infinity. Guess what? That is going to be does not exist because they cannot reach the same conclusion. And that's that. That's that. Now, what happens if you have this? Limits. Again, I'm going to approach to 1 in this case. 1 over x minus 1. And I'm going to say square. What happened here? Why? Right. So, but you have to test them, right? Limit x approach to 1 from the left. Now I'm going to plug in, say, 1.9 minus 1. Oh, sorry, 0.9. So it's going to be 0.9. And square, so that's going to be positive infinity. Limits x approach to 1 from the positive side of 1 over x minus 2 minus 1 square. So it's going to be 1 over 2.1 minus 1 square. So regardless, it's going to be positive infinity. So this equal to positive infinity. So you can get positive infinity. However, we also talked about inbound behavior before. We said that is part of limit does not exist. So the answer could be positive infinity or does not exist. But both answer choice not gonna be coexist in one multiple choice question. They either does not exist or positive infinity. Just even this textbook alone, chapter 1.2 says this is a limit does not exist. Chapter 1.3 says this is going to positive infinity. So what I'm trying to say is, from what my teacher taught me in Dr. Phillips, she was one of the best in the nation. She says, according to AP board, they will not give you both answer choice present in one problem. They either going to be positive infinity because you verify both sides positive infinity, or going to be like does not exist because due to vertical asymptote. Okay, but it's not going to be both answer there, so you don't have to worry about that. This is what she tells me, and I believe her because she's one of the head grader in AP exam, and she's been head grader for almost 20 or 30 years. And she's the best. She's just flat out. Every student gets 5. I don't think I can ever do that, but is that okay? So this is a pretty easy case, right? So that's why I say I don't know. I don't know if I'm gonna assign homework. I'm just maybe assign a big review tomorrow for you guys go over. So what's the other possibility that you can have? Well, this interesting case right here. This interesting case that we did not really focus on, which is absolute value. And absolute value asset, you might have to do this one side limits, because absolute value you want to think about in terms of piecewise function. So P-I-E-C-E, piecewise function. And then we had to do it one side at a time. Let me give you an example. Let's say if I have limit x approach to 3 at absolute value x minus 3 over x minus 3, like this. So that's why I said this could be both. Sometimes it could be here, sometimes it could be one side limits. It's interesting. Then you say, well, what do I mean by that? What happens if I approach 3? What'd you get? Well, if you plug in limit, the first thing you do is what? No. No. It just plug in the value. So it'll be 0 over 0. So it's not undefined. It's like indeterminate. Now you realize that this question, it doesn't belong in 0 over 0 or number over 0. Just because this situation kind of tells me something more. There's absolute value. There was actually a jump, but we got to prove it. So let's talk about absolute value x minus 3. So let's graph y equal to absolute x minus 3. Does anybody know how to graph y equal to x minus 3 absolute value? How?
Go over 3 and just
Right. So it's going to be 1, 2, 3, like this. Because inside the parenthesis is going opposite directions. You're shifting right 3 units. So this part of the function is actually called x minus 3. Remember that definition of absolute value, you can write in 2 different ways. Second way is going to be this way. It's going to be black. And this one's negative x minus 3. So if you do that, you change the absolute value to this. Now also that the problem is you're reaching 3. And you got 0 over 0. Are you reaching 3? And reaching 3 is going to be 0 over 0. So you say, okay, well, how about I approach one side limits? So this is the case kind of between both. Either it could be one side limits or it could be this, but it's still over 0 over 0 cases. So this is kind of vague in between two. It's like, you don't know what happened here. So what I'm going to do is I'm going to do one side limits. I'm going to do limits x approach 3 from the positive side. If I 3 approach the positive side, which equation do I use? Do I use the black function or the blue function? The blue function, right? So it'll be x minus 3. And I don't worry about absolute value anymore because I only choose 3 from the positive side. And this is x minus 3. And this will cancel out. This will happen to be 1. And you say, okay, if we reach from 3 from the positive side, it's 1. How about limits reach x approach 3 from the left side? Well, we don't know because on the top, we're going to choose the black part, right? And that will cancel out. That's going to be negative 1. So it turns out it's going to be 3. And it's going to be like this. It's going to be like this. And we've seen this graph before. Because one side's 1, one side's negative 1. But if you reach 3 from the both sides, guess what? What is this answer? What is the answer? What happened is this answer. You already approached 3 from the left, 3 from the right, and you are inconclusive. So what will be your answer? Does not exist. But you had to reach from 2 different ends to decide that. Because if a single value, you had to approach from both ends. You had to decide, hey, dude, is this positive or negative? And if you go, oh, this one's positive and negative, that means there's no answers. Does that make sense? So you can choose equation from both sides. Now, this you had to from both sides because 3, so then you say does not exist. Yesterday, I have a questions, right? The last question with the absolute value. Do you guys know how to do that one? What was the question? Was x squared minus 4 over absolute value x minus 2? And it's asking approach 3 different ways. Do you remember that? Do you remember this question or no? Is that a question? So can you guys tell me what's the answer for each one? I don't know. Did you work out? I don't know. It's right because. Yes. But can you show me the work? Even better, can you graph it? That's even better. Oh, I should ask if you know how to graph it. That's a better question. Graph of this question is also interesting. Matthew, what'd you do, man? Your energy just so strong. You got pulled. The object just pulled towards you, right? That's literally what happened. Can you graph this function even? Do you know what a graph look like? Interesting. You should try to graph it. Let's do 2 from the left first. So what would it be? Limit x approach 2 from the left, right? This is x plus 2 and x minus 2, right? What happened at the bottom?
Negative x
Negative x minus 2. Good. So this cancel out. If you approach 2, that's going to give you a negative 4, right? But the function is also is negative x minus 2. That will end up being simplified. So I'm going to put that aside first. And if I do this one, it's going to be limit x approach to 2 from the positive side. So it's x plus 2, x minus 2, and then x minus 2. And x minus 2 cancel out, so be limit x approach 2 from the positive side of x plus 2. And that's going to be 4. So it turns out that if you graph it, right? I'm going to graph greater than 2. 1, 2. I'm start with 2, 1, 2. And it's going to go up 1 by 1. So it's going to be, so it's going to be start right here. Because it start right here. But I'm not start graphing until this part. Do you see that? And that's an open circle, right? And what happened the other side? Well, we're going to graph negative x minus 2. So it's going to be like this. Here, here, and here. So do you see that graph? It's 2 things off each other. And of course, that part just does not exist because this is a jump. And if you graph this on a normal graphing calculator, it will come out to be like this. But then you say, how do I graph it? I just graph negative x minus 2 when x is less than 2. And I graph x plus 2 when x greater than 2. And I'll keep an open circle on both ends. And therefore, this is called jump discontinuity. Right? This is a very, very cool one. And yeah. No, that'll be a graph of x squared minus 4 over absolute value x minus 2. Actually, I'm gonna graph it for you to show you before you think I'm lying to you. Because I could lie too. I'm a good liar. The top was x squared minus 4, right? And this one, oops. I really hope they don't have
It wasn't absolute.
oh, it's the absolute value is on the bottom. So let me do parentheses then. Absolute value what? Yeah.
So I'm gonna try it. So for the rational function, like the 1 over x minus 2, we plugged in like 1.9 and 2.1. And we got negative infinity plus. So this, would we call this a rational function as well? Because there's a.
This is kind of like, it's a rational function, yeah, but there was an absolute value implement in there, so it's.
So can you ever have infinity or negative when there's the absolute value? Like, is that possible?
You can. So for example, that you can have some situation like this, right? We just flip them. So very good question. You say what if, right?
Yeah, like if you like plug in like 2.
Divided by x squared minus 4. That you can have some cool stuff like this.
Okay, that's less thing.
You can have a jump on 2, and there's an asymptote on left side. That's pretty crazy.
Yeah, that's
good question.
So it's a weird.
Yeah, so there's actually an asymptote at actual -2, but at 2 there was a jump. Yeah, that's a good question. Yeah, I love math. It's like a lot of people just like trying to memorize how to do math.
Yeah.
But I like Daniel is because Daniel tried to think about what if. Like today, a pre-cal asked me a question. I don't know how to answer it. I confused myself. So there was a pre-cal question like this, right? The pre-cal question was -4 times square root of -4. What do you think the answer is? What? Why?
Multiply the square root of something by itself, and you just get rid of the square root sign. This is root -16.
No.
Because I don't know. I think I figured out that you asked me.
Yeah, so there was a rule like this, right? The rule says there's a rule like square root a times square root b is equal to square root ab, and this will always hold true if a and b both positive. Now, if they both are negative, then this rule does not work. It's written in a textbook. Math teacher don't talk about it, but it's actually interesting because if you do square root of -4 times square root of -4 equals square root of 16, and that should resolve with 4, right? But the technicality, if they both are negative, so Matthew, this is a question that is interesting because if they both negative, technically, if you do it, it's just square -1 times square root of 4, square root of -1 times 4, and that's going to be square root of 16 and the I square. And I square should be -4, and that's my answer. The true answer is -4, not +4. Okay, on SAT, this is the right answer. +4 is the wrong answer. But here's the thing, that there's a rule like this, right? Now, how about A over B? If they both are negative, right? If I say square root A over square root B, and that's if they both are negative. So McKenna asked me this question on first period, and I didn't know how to answer. What if they both negative? So technically they cancel out, right? But do you see what I'm saying? That was a kind of interesting question. Is if they cancel out, let's just say square root of -4 over square root of -1. And this is the part I'm confused about. Is if that's I square root of 4 and this I whatever, right? Just I. So I cancel out, that's equal to 2. But shouldn't that be -2? This is the thing. It's like, no, they should not be -2 because they cancel out. So that's like, I'm confusing about that part. That part is like very interesting. Why the rule only apply for multiplication, but not division? And that was like one of the pre-calc question that I'm kind of stumped in some way. Like I didn't never think about that situations. And she asked a great question to start with. So I thought that girl was very smart. It's she's asking what if.
If you do like square root over -4, I mean root -4 over no, because like if you do the root over the whole thing, since it's on both numbers, it's like -4 over -1. And you just make that 4, so it's root 4. Isn't there
There's like a there's some like I don't know like
Right, so
something.
why is it possible to do that for
Yeah, and that's her question, which is very valid. I thought she's very smart. Like she's very smart by asking that questions. Like she's thinking about what if the other way. So yeah, so I gotta figure out like how to answer it better. But I think they just cancel out.
about like the plus minus?
Huh?
That factor into it, like the plus minus?
No, I don't think so. You're not supposed square root of 4 is not supposed to get plus minus 2. So square root, okay, so that's another confusion for a lot of advanced students. Square root of 4, why that doesn't equal to plus minus? Square root of 4 is only 2. Now x squared is equal to 4, x equal to plus minus 2. That's another confusion from a lot of students too, but this is true. But yeah, I thought it was a great question. I'm very impressed about that girl.
No homework?
Yeah, that's too easy. I'll give you all tomorrow. Huh?
What are you doing tomorrow?